Hi, folks. We thought we would put a video together going over all the different points of this particular graph. This is the idea of what is a limit visually? What does a limit look like? How can it be interpreted graphically? What should you be thinking about when you see this algebraic stuff later as far as the behavior of the function? This is why we did so much review of behavior of the function. So copy this graph down if you haven't already. Make sure this is in your notes. I'm going to go to another page that has some examples on it that we can work with. So I'm sure we talked about -3 in class. Let's take a look at -1. So the limit in general, what we're looking at is the limit as x approaches some number. So this is like where, right? We were talking about what versus where when we were doing function behavior, the 25 questions, what versus where. So where are we looking at? Where are we looking at? Where along the x-axis are we looking at? Where is x? Right? And then the limit of that function, the L part over here, this becomes, well, what's the value, right? Or what is the value approaching, right? So this is the where versus what, the y versus x, right? So let's take a look at -1, for example. As x approaches -1, and the little minus sign here means from the left. As x approaches -1 from the left, that's the function. What is happening here? Close to -1, but on the left side of -1, to the negative side of -1. Well, the function is going down indefinitely, so that becomes -infinity. Right. As the function approaches -1 from the right, -1 from the right. Well, now we're looking to the right side of -1. We're looking here for our x values, right? As close to -1 as we can get without getting there. Notice we actually don't get there. So these values here are approaching a y value of 2. Okay. So then finally, the limit as x approaches -1 in general. -1 in general. Well, because the two side limits don't match, we have it does not exist. Now, it also might always be interesting to look at, well, what is f of -1? What is the function's value at -1? Well, it also doesn't exist because there's no particular point here. We have an open circle here. There's no value given. It's a domain restriction. All right, so there's -1. I'm going to go on to the next value, pop through a bunch of these values here. Let's see. Along here between -1 and there's just a line here. There's nothing particularly interesting going on here. If we wanted to take the limit, we could take the limit at any value we want. We could take the limit as x approaches 0, for example, from the left. Nothing particularly fancy going on here. 0 from the left, here's our x equals 0. It's the y-axis, of course. So what's happening here? Oh, we're getting near 3. As we approach 0 from the right, well, now we're riding this line again towards the same value, towards 3 again. Because we're just riding on a line towards x equals 0. And then if we have the limit as x goes to 0 in general, because the two side limits match, that's also 3. And in this case, it also happens to be that f of 0 also equals 3. So all those things match when a line is just behaving, just the function is just behaving. It's doing its normal thing. Not particularly interesting. Not particularly interesting. Okay, but still, you can still do limits for it. Let's see. We can also look at 1. If we look at 1, we have a point going on here, so it's a little interesting, right? So as we approach 1 from the left side, the y value is 4. As we approach 1 from the right side, the y value is also 4. As we approach 1 in general, the value is 4. We're really looking at this point. We don't care so much if we get to this point or not with the limits. If this was an open circle, these answers would all be the same. But in this case, f of 1 also happens to equal 4, so it's not an open circle at all, right? This idea of what a function value is very different to the ideas here about the function value approaching, right? Even though in this case, everything's the same. Let's look at the next value. Let's look at 2. What happens as x is approaching 2 from the left? that's going on here, right? We're getting towards this open circle, right? As we go from, let's say, x equals 1.9 or x equals 1.99 or 999 or 999,999, like we can keep getting closer and closer and closer to this x value, but we can't get there, right? Because this is an open circle. We cannot actually get there. But our y values are going to get closer and closer to 3. All right, our y values are getting closer and closer to 3. As we approach x equals 2 from the right side, now instead of thinking about 1.9999999, we're talking about like 2.000000001, right? Or 2.000000000000001. Like it doesn't matter how close we get. We're not going to get there because 2 is a domain restriction. But we are going to get closer and closer to the value of y equals 3. So that's our limit. Okay. Now, because the two side limits match, the limit of f of x as x approaches 2, the limit as x approaches 2 of f of x can be said either way. Limit as x approaches 2 is 3. Right? But in this case, f of 2 does not exist. Right? Right? Because this is a different idea. This is what the f of 2, that's what the function is. That's algebra, what the function is. The limits is, well, how's the function changing? You know, it doesn't actually get to 3, but we can imagine that it wants to get to 3. It's approaching 3. Okay. All right, let's look at another number. Let's look at 3. As x approaches 3 from the left, well, from the left, we are getting closer and closer to a y value of 2. As x approaches 3 from the right, that's over here. Well, even though f of 3 equals 2, just to the other side of 3 at 3.0001, there is no value. So we have a domain restriction. We also have a does not exist for a limit. We can't have a limit if there's no function behavior. If the behavior is not doing anything at all for any values near it, that just isn't happening. Therefore, our general limit, since the two side limits do not match, our general limit is do not exist. Let's look at 4. 4 from the left. 4 from the left. That means over here, like 3.8, 3.9, 3.9999999, right? Nothing's happening, so that's a do not exist. 4 from the right. 4 from the right. Well, 4 from the right, that's over here. And this function, as we get closer and closer to 4, it goes up uncontrollably, right? So it goes towards infinity, right? Which is really an idea. It's not really a value, it's an idea, but we still think of a function as going towards infinity if it's getting closer and closer to a huge number. All right, and that's actually the behavior as we're approaching an asymptote. Then the limit as x approaches 4, the two side limits don't match, so we have a do not exist. All right. In this case, also f of 4 does not exist because it's a vertical asymptote. All right. And lastly, let's look at when x, we're not going to use this minus sign, when x is approaching infinity, when x is getting bigger and bigger, when x is going out bigger and bigger, the function seems to be approaching this asymptote. Right? You learned about asymptotes last year. It's trying to get closer and closer to 2. It's trying to get closer and closer to 2. So that's an asymptotic behavior or an end behavior, an asymptote, right? End behavior, right? We can also talk about when x is approaching negative infinity. I'm not going to ignore that plus sign there. Negative infinity, right? That's what's going on over here. As x goes that way, it looks like y is going down, right? So this also is negative infinity. All right, kind of like the 4 was positive infinity from the right. All right, so there's an overview of everything on the graph. This is visual limits, right? We'll talk about algebraic limits soon. This would be very complicated to talk about algebraically because it's a very complicated piecewise function. But this gives you the visual idea of how behaviors are around particular interesting points.